Greeting learners. In the first part to the introduction of prestressed concrete structures, we say what is prestressed concrete structures and how it is different from reinforced concrete structures. In this part 2 video lecture, we will be seeing about other learning outcomes like what are the two major types of prestressed concrete structures, how the force is transferred from tendon to the concrete section, and how the tendons are stressed, what are the various tensioning devices used in the construction of prestressed concrete structures. So basically there are two types of prestressed concrete structures. One is pre-tensioning of concrete, another is post-tensioning of concrete. As the name suggests, the tendons in pre-tensioning of concrete, the tendons are stretched before the concrete is hardened. The tendons are stretched before the concrete is hardened. In post-tension, the strands or tendons is stretched after the concrete is hardened. You can able to clearly understand what is pre-tensioning of concrete and post-tensioning of concrete by how it is made, how both these type of prestressed structures are made. So these two differ in the method of stressing the elements, how the force is transferred from tendon to the concrete element. That's how they varies, and also the construction sequences will vary. First we will see about pre-tension of prestressed concrete. Here what is given is the beams or elements are constructed on a stressing bed and standard cable is placed between two buttresses and anchored to a stressing bed which holds the force in the stretched cables. After stretching the steel with hydraulic jacks, concrete is placed in forms around the cables and allowed to harden. When the concrete reaches sufficient strength, the prestressed force is transferred to the concrete by bond. Here that word is very important, by bond, when the steel strands at the ends of the beam is cut loose from buttresses. So I will explain what these 2 points are given by this diagram. So here in the first topmost figure, you will having an end abutment, both two end abutments, and the red line is steel tendons. So even before placing the concrete, even before pouring the concrete, you will be stretching the steel tendons. The right hand side of the end abutment, you have a brown color jack. The jack will be used to stretch the tendons. Once the tendons are stretched, you will be having a force in the tendons. Once the tendons are stretched, in the second figure, casting of concrete, you will be placing a mold, you will be pouring the concrete, and as usual, you will be curing the concrete. Once the concrete attains a particular hardening state, the tendons are cut from the end abutment. The tendons are cut from the abutment. Since the concrete is hardened, the tendons will not be able to freely move, freely relax in its position. So it will take concrete to its position. So basically what is happening is the force we applied in the tendon is transferred to the concrete. But here we have applied force in the tendon before even pouring the concrete, before hardening the concrete. And here there are 2 points. The 2 points you have to note it very clearly. First one is the tendons are stretched before hardening of concrete, and second one is the force is transferred from tendon to the concrete section by bond, by touching surface, by interface. These are the 2 main things we have to note. This is pre-tension, prestressed concrete. So these are the real life pre-tension concrete beams. As you can see, the lines are tendon strands, and the end abutment here it is in a form of steel. So in pre-tension concrete beam, you have 2 things. The tendons are stretched before making the concrete, and once the concrete is hardened and the tendons are released, the force from the tendon to concrete section is made through bond. So what is post-tension prestressed concrete? It is very similar to how the ordinary concrete is made. Here first the concrete is made with leaving a duct or hole in the concrete beam. Once the concrete is hardened, the tendons are inserted in the duct and is stretched. While stretching itself, the force from the tendons will be transferred to the concrete section. So here what is given is steel cables inside plastic ducts or sleeves. It is called as the whole, what I am saying is called as plastic ducts or sleeves are positioned in the forms before the concrete is placed. Afterwards, once the concrete has gained strength, the cables are pulled tight and anchored against the outer edges of the concrete. So here what is happening? You have to compare both pre-tension and post-tension. There, even before making the concrete, the tendons are stretched. Here, once the concrete is hardened, then only the tendons are placed inside the duct and stretched. In pre-tension prestressed concrete, the force is transferred from tendon to the concrete section by bond, by connection, by interface. But whereas in post-tension concrete, the force is transferred from tendon to the concrete section at the anchorage, at the ends by anchorage. So these are the main differences. This is the difference between pre-tension concrete and post-tension concrete. So in pre-tension concrete, you will be stretching the tendon before making the concrete, and the force will be transferred from tendon to concrete by connection, by bond. Whereas in post tension, you will be leaving the duct, and once the hardened concrete is made, the strands are placed inside the duct and are stretched, and also the force carried by the tendon is transferred to the concrete section by anchorage. So there by bond, here in post tension it is by anchorage. So this is as you can see, these are the rolls of post tensioning cables. This will be placed inside the duct once the concrete is hardened. So these are pulling anchors at the end. The bottom figure is slabs, which is pre-stressed. Once the tendons are placed, as you can see, there are a number of lines over there. These are the strands. So as you can see, there are a number of circular holes at the bottom of the slab. These are called, this is what I am calling as duct or sleeves. Once the duct and the sleeves are there, once the concrete is hardened, inside the duct the stands are placed. Once after that, as you can see, the hydraulic jack is used to stretch the stands inside the cables. Normally, pre-tensioned prestressed concrete beam is made in a shop, means in a job site fabricated away from the job site. Whereas post-tension, normally it can be made anywhere, and while the stretching take place at the wall. So these are the various tension devices used to apply force in the tendons. The first one is mechanical devices. The mechanical devices generally used include weights with or without lever transmission, gear transmission in conjunction with pulley blocks, screw jacks, with or without gear devices, and wire winding machines. These devices are employed mainly for pre-stressing structural concrete components produced on a small scale in factory. So these are like old school methods. Here you will be using a pulley so that you can rotate the wheels. So it will transfer load to the tendons. The major popular thing is hydraulic devices. These are the simplest means for producing large pre-stressing force, extensively used as tensioning device. This is the most common used hydraulic devices. It will be very small in nature, and you can apply large amount of force through the tendons. The third one is electrical devices. The wires are electrically heated and anchored before placing concrete in the wall. This method is often referred to as thermo-prestressing, used for tensioning of steel wires and deformed bars. These are used for minor purposes, and only small amount of forces can be transferred to the tendons. The last one is chemical devices. Expanding cements are used, and the degree of expansion is controlled by varying the curing condition, since the expansive action of cement. Here by properly varying the curing of the concrete, condition, and due to hydrothermic reaction of cement, some percentage of force can be stressed into the tendons.